sidebar. If you click on it, it brings up a Choose Model menu and then a browser window, a tree window. It opens up the default SysML modeling domain. As you guys know, you can develop your own models, and I'll show you shortly how to do that. If you mash the Choose Model button, if you've got some other models created, then you can pick them. So I've got one here called SysML Automobile. I'm going to go to that one, say OK, and then it redisplays a set of models and packages. In SysML, as you know, a package is like a folder. And so there's one top-level model, and then you can have a hierarchy of packages. These are up to you on how many packages you define, just a way to group your information. You notice here I've got a package for use cases, for requirements, for behavior, for structure, block definition diagrams, and internal block diagrams, and constraints. If I expand one of the packages, for example, use cases, then in that package, I can see any diagrams I've got created. I've got one diagram created, and you'll notice it has the UC, that's the use case diagram type. And then there's an elements folder. The elements folder will contain all the elements, all the stereotype elements that have been defined in this package. So this package owns these elements, these stereotype elements. It's just like a tree, like a normal Cradle. So if you expand, for example, let's expand open door, then you can see that I've got traceability or relationships to other SysML elements. Here is a link to an actor. Here's a link to the block, the automobile system that we're going to do the use case for. And then there's links to other diagrams. So I'm going to open up this use case diagram by clicking on it. It opens it up in the center pane. And if I come up here and click on the tab title row, I can get myself more display area. And we'll make this, slide that over a little bit. So this is a use case diagram in SysML. We've got the stick figure actors over here, where we're trying to identify the stakeholders that have an interest in this particular system. The rectangle here, called automobile system, that's a subject system of interest that we're designing. The ovals represent the use cases that we've specified for this particular system. We're going to open the door of the automobile. We're going to provide riding comfort for the vehicle occupants. And then we've got a generalization over here to two other use cases. Control the climate inside the automobile and control noise and vibration use case. Then down at the bottom, I've got an operate vehicle use case. You'll notice that we've got another compartment in the use case here. This is a cross-reference link to two scenarios. And by a scenario, I'm talking about an activity diagram. As you know, normally in a use case, you can define a textual description of the activities that should be performed for that use case. Or you can build an activity diagram and show those activities. So if we want to look at one of these activities, I click on the symbol, and do my right-hand pop-up menu and go to links, all linked items, this has given me a list of the elements and diagrams that are linked to this open door use case. You notice I've got two diagrams here. One diagram is the use case itself, and the other diagram is an activity diagram, the scenario called Unlock the Vehicle. I want to open that up by clicking on the icon, and it launches an activity diagram. In an activity diagram, when it opens up the diagram over in the sidebar, it expands the diagram control sidebar that's got the symbols that are legal to draw on the diagram and some other information. So you notice here I've got the black dot, which means start the activity. And in this case, we've got a dashed arrow to represent the control flow. So we're going to start at this point and go down here to select unlock action. That's this symbol right here, action. Once we perform that action or unit of work, we exit and enter the key code action. Now, in SysML, you can define what's called a pin, attach it to the action. This is to show inputs and outputs. So this action here has a single output item called key code. So enter key code action is prompting the user to enter his key code to get in his automobile. Once the key code is received, it's passed through this solid arrow that's showing data flow, where the dotted line is showing control flow. So we're passing data, the key code, to this action, verify key code. Once that action is executed and performed, then it exits into this decision. Over here is the decision symbol, and it has one entry and multiple exits. So we've got a valid exit coming out of that decision point or a not valid exit. So if the key code is not valid, we take this path, come down here and execute a wait function action. And we're going to wait for 45 seconds of time. So after 45 seconds, then we're going to exit this wait action and perform this send signal. So this shaped symbol represents sending a signal somewhere in your model. So we're going to send this intrusion alert signal after 45 seconds if the key code is not valid. If the key code is valid, we take this path, we're going to send a signal that's going to sound a beeping signal to let the user know that it's okay to enter his vehicle. Once that's sent, it's an asynchronous message. Once that asynchronous message is sent, we exit and take this action, open the lock on the car, and turn on the lights. So it'll turn on the lights for us. And then we exit, and we're done with this operational scenario using an activity diagram. It's very easy as you're engineering your model here to add new symbols. So if I want a new action, I just click on the symbol I want to insert, go into the drawing area and click with your left mouse button, and it should come up with a name symbol dialog where I can give this symbol, this action, a name. So I'm going to say enter car and say OK. And I've added a new symbol. And then I can start connecting the symbol to other symbols describing my behavior for this diagram. Okay? Now, as I'm defining these actions, I'm understanding, based on the use case, what the actions need to occur to accomplish that use case, and that gives me a clue about the functional requirements for our system. So at some point, I'll want to create a requirement item and link it to my actions that are being satisfied by that requirement I'm going to create. And I'll come back to that in a few minutes. So now, let's close this activity diagram. And we'll come back over to our sidebar. I've edited the diagram, so it's updating the diagram. So now back over to our sidebar. And if I expand the folders beneath the diagram, that's showing us the information captured on the diagram. So for my use case, I didn't make any changes, but I did change an activity diagram associated with this open door use case. So that if I go to my folder down here called behavior and end it, you'll see I have 3 subfolders. I've got one for activity diagrams, one for sequence interaction diagrams, and one for state machine diagrams. The 3 kinds of behavior diagrams in SysML. Now I could have put all my diagrams in one folder if I choose. It's up to me. So if I expand the activity diagram folder, I can click on it here. You'll see that that package has several activity diagrams in it, and then this folder containing all the elements that are owned by this particular package. Likewise, underneath each diagram, so one we were in a minute ago was called scenario, unlock the vehicle. So let's find it here. Scenario, unlock the vehicle. If I expand it, and if there is my actions on that diagram, so let me just reopen it so you can see what I'm talking about. So these are actions, okay? And if I go into the action folder, you notice I created a new action called enter car. And so there it is, enter car. So as I created on the diagram, it adds it over here in my sidebar so I can link requirements to it or link trade studies to it or risk or issues, whatever I need to link by just dragging and dropping like in normal Cradle. The wait time action, remember that's this symbol over here. It looks like a timer. And if I expand that, you'll see I've got one of those actions defined here on the diagram. All right. Now, as I'm defining these actions, I get an idea about what functional things that my system has got to perform for this use case. And then based on the functions, I want to start thinking about, well, what is my system going to be made up of? So I want to go over here to my folder called structure and look at a block definition diagram. Because here I've got actions, but I haven't identified what thing, what structure thing is going to perform each of these actions. So I can come down here and create a block definition diagram. Then I can allocate my actions to my subsystems, my hardware, my software. So if I come down here in this package called structure, I've got a block definition diagram. That's got like a schematic block diagram. I've got 2 of those, and then an internal block definition diagram. The first one is called automobile context diagram. So this is kind of my black box view of my automobile system. So if I click on the diagram and open it up in the center pane, let's expand a little bit so we can see what we've got here. Here we've got an abstract block called Automobile Enterprise, and then it has other blocks associated with it. This hollow diamond is a share indicator that this automobile system is shared by this automobile enterprise block. And so is my electronic test equipment, so is my baggage, my suitcases, and my people, my passengers. So the purpose of this diagram is to nail down the system of interest I'm trying to design, and then the external systems I have to interact with. So I know my automobile has got to be able to handle baggage. It's got to be able to operate in whatever atmosphere, natural environment. It's got to operate on whatever roads that I'm traveling on. Now, inside SysML, a block can be segmented into compartments. So if I come over and expand the bottom icon again, the control sidebar, you'll see over here for a block, I've got different compartments that I can display. I've got values checked, like a state value or state variable. So here, the variables I've got defined is steering angle for steering the vehicle and gas mileage per hour, 2 variables defined. Now, as you remember in Cradle modeling, if I highlight a symbol and use my right-hand pop-up menu and say rename, then I can change how many characters are being displayed. So let me just make that 30 characters. The reason I did that is so it wouldn't word wrap those 2 variables. So gas mileage per hour is 1 variable, and steering angle is another variable. Now, in SysML, a variable is defined by a stereotype called value type. So if I come over here and look at the sidebar again, and look under this diagram that we're working in, expand it, okay, expand the block. Now, the block I'm looking at is automobile system. So let me find automobile system. There it is right there. And you notice that it's got what we call a qualifier name. Because a block or an element of any kind of SysML can be owned by different packages, the idea is one package will be the owner or the container, like a namespace. All other packages can reuse that element. And so the qualifier name is showing the owner. So in this case, automobile system is owned by SysML automobile model. That's up here at the top. And then package 2-use cases. So this guy right here. So remember, we created our use case. There's our block. So automobile system is owned by this package because that's where we created it. But then we're using it down here in the structure package, so it's showing up with the fully qualified name of the owner package. Now, if I expand that, Cradle is a little bit different from some of the other tools. Cradle is not just a modeling tool like No Magic, Magic Draw. It is a system engineering support tool with a traceability. So the way we fill in data for these compartments is not a type-in field. These are live objects that are cross-reference linked to the automobile system. So if I look at automobile system, here's operation property, operate the vehicle. So let me come over here in my sidebar, and let's open up another compartment called operations. Operations is SysML speak and UML speak for the activity that this block is going to perform. It's like a service that this block is going to perform, a functional service. If I click on it, you'll see it expands that compartment and shows me the three activities that are being provided, this PROV, that's in SysML 1.3 and later nomenclature for defining that these activities are provided by this block. If this had been REQ, then that would mean that somebody else was going to have to provide this activity. So if I come back over now to look at my sidebar again, I want to show you where this information is associated with this block. So click on your sidebar. There's the three operations. You remember in Cradle, when you get a tree, you can highlight the indented element and do a right-hand pop-up menu and say link details. So this automobile system is cross-reference linked to operate vehicle activity. You see the stereotype here? This stereotype is block. This one's activity. And they'll link together with this link type or relationship name called operation property. So that's how we link this activity to the block to have it to show up in the operations compartment, but using the relationship called operation property. So these properties are going to show up in the operations compartment. Okay? Now, you'll notice that this got this provide indicator. If I look at the link attributes, remember a link, a cross-reference link in Cradle can have link attributes. If I expand on attributes, then under properties here, I click the ... that pops up a menu where I can specify the requested behavior. So the legal options are that an operation can be linked to the block and marked as provided, and that's the one I've got selected now. You see the check mark here or the radio button, or it could be required, or it could be provided and required. So let me just do required, say OK. So it changed this link attribute value to be required. If I save that change, say OK. Now I probably have to do a refresh to have it show up here. Let me see if I can do that real quick. Hit refresh. You see there? So this is an attribute on the link between this activity and this block. That's the way we show information. Now let's see if we've got another compartment. Let's go over back to the control sidebar. I'm going to select the block. It shows me all of the various compartments. Let's look at flow properties. Inputs or outputs, I/O. So you see here I've got three flow properties. Ignition on. Whenever I turn the ignition on my vehicle, it's going to start the car, right? Start the motor, start the engine. If I turn the ignition off, it's going to turn off the engine. And if I turn the steering wheel, it's going to turn the vehicle. So these are three other elements, stereotype elements in SysML. And these are, let's see, what are these things? Let's go back over to our sidebar and let's just double check. It doesn't tell us right here, right now, but we can see it from right here. So this is a flow property. So let's look for the verb, the relationship called flow property. There it is right there. So these are signals in SysML. So ignition on or off, that's a signal that's going to get generated by the operator, the human, into the automobile. You notice here it's got the N These are inputs into the vehicle. And again, if I want to look at the link attribute for ignition off, highlight the flow property element, do a right and pop-up menu, do link details. Here it tells me block called automobile system is linked to signal called ignition off using the link type flow property. Then the attribute, the link attribute, is set to direction in. If I want to change that, I can make it direction out. So it's an output from the block rather than input to the block. And I think this gives you a feel for how the compartments are created. They're created from cross-reference linked information. Everything in SysML is an object made up of objects. So they're elements linked to elements linked to elements. And the reason of that is for reusability. So I can reuse an object anywhere on any of the 9 diagrams. So let's do our refresh again. Now you'll see down here, ignition off is now an output instead of an input. So I've changed the specification for this particular block. Okay? Let's close that. Let's come over it. So we've looked at the activity diagram so far, and we looked at a block definition diagram. Let's come back and look at a couple more activity diagrams, and then we'll go on to one of the other kind of behaviors.